Okay, what you guys have in your hand today is Lab 1. Lab 1 will cover the hardware install. So what you're going to be doing is actually installing your station, making that particular station light up, and you'll be able to do some, just small portion of troubleshooting, but we're going to go to details later on after lunch. So we can read through it. The purpose of this install is to actually do the physical wiring. There's some prerequisite in this lab is the ability or the understanding of low voltage wiring. So if you're familiar with low voltage wiring, this is a perfect application where you want to do this and understand PoE power over Ethernet. The goal for the trainees is to actually understand what a node is, what a PSE is, power supply or Cisco switch, and understand the collaboration. How do you physically put this thing together? Some of you who might be actually putting it into the drawings, it's one thing, but for these guys, they will be actually putting it together. Number one is connecting. I'm just going to read through the 6 elements, and then we'll go over them one by one. You got to connect 2 downlights. You got 3 downlights on every station. You're going to connect 2 of them to one driver, and you're going to connect the last downlight into another driver. You're going to connect your wall switch into the control portion. So think about it as one room. You got 4 separate rooms, and you're going to connect your 2 lights under one driver. And from the same node, you're going to connect the second driver into another node. And then you're going to connect your wall switch. Then you're going to turn it on and make sure it does turn on. Press the up button. Don't try to press the on button, because that will give you a lot of light and it'll just shine on your face. The up button instead of the on. When you press the wall switch, if you press on, we've seen in the past, so you press it, too much light goes on your eye, it's not pleasant. And then we're going to trace the cable and find out where this thing lands. And this is going to be a collaboration because there's only 4 cables, so you guys are going to work together to find out where every station lands. Let's start. So all of you, you don't need a laptop for this. You got connectors or wires or RJ45 patch cords to your right-hand side. Yep. You're going to connect driver 1 to the 2 downlights. And then you're going to connect driver 2 into the last downlight. And then you connect the wall switch. All the connections happen in the background. These stations are taped in. Actually, they're sticking into the desk. So you might have to, if you want to stand up and find out where they are, you can do that. So how do I know where's driver 1 and where's driver 2? And what does that mean? Why there's driver 1 and driver 2? So all our nodes have 2 outputs, and those 2 separate drivers. When we talk about driver 1 is if you look at PoE, is the one straight down. So driver 1, driver 2. Driver 1 is on the right-hand side, driver 2 is the one after. So there's 2 true outputs out of this node. Driver 1 is on the right-hand side, driver 2 is on the left, if you're looking from the top. So everybody can see that the only thing that I noticed is that driver 1 and driver 2. And that's important, because when there's a layout and we have a CAD and we laid out and we tell that we wanted driver 1 goes to 2 lights and driver 2 goes to 1 light, the output here says luminaire. You're going to have an instruction, but usually when that gets to the field, it gets thrown out. And nobody knows where's driver 1 and driver 2. So keep in mind that driver 1 is the one straight across from PoE, the one if you're looking from the top to the right. However you can reference designate. Okay. Now let's do this. We did all this. Now we want to find out where's everybody's PoE cable, which is a white cable, lands here on the switch. So if we can see that all these 4 cables are coming underneath and go into here. If all of 4 of you, and you get a call and someone says station 2 has a problem, what are we going to do? We got 4 cables. How do I know where they land?
You have to pull one by one.
Good one. Pull one by one. If you do that and you have 24 ports, you're going to have to pull 23 ports before you actually find out. If you're lucky, you can pull the first one.
They're not labeled.
Thank you. So they're not labeled. Very important. Pull schedule is mandatory. We have to know. You guys are hands-on in the field. We don't know where this thing lands. And if you get in a call to troubleshoot and you don't have an actual label, you won't know. It's like you're the electrical company in a neighborhood and they're telling you there's one house that doesn't have light. How do you know that? You won't until that actual house gives you an address. We need that address. We need to know where every light or cable got connected. And that's a pull schedule. You need to tell us what node got connected to what port. And if it gets swapped, we need to know that. Perfect. That's another one. Instead of going to the switch and doing that, you can do it on the device itself. Assuming you have all 24 connected, or maybe you take a picture, a snapshot of this, and if station 2, take the white cable off, and the rest if you want to come here and see. All the 4 cables are green blinking. You disconnect yours, station 2. Take the white cable off.
It gets, stops blinking.
Yep, and it's off. And now we can identify what port it is.
Yeah, usually we do that with the phone cameras.
Exactly. So in the camera world, you do the same thing. You can do it on the switch or we can do it there. Same exact thing. Can I have 2 lights after the splitter, 2 different wattage lights? No, you can't. You can only put, if I'm coming out of the splitter out to the lights, those 2 lights have to have the same wattage. You can't put a 10-watt light and a 14-watt light after the splitter. It won't work, or it would actually light dimmer than the other. So you have to only spec the light after this splitter to be the same wattage or same type.
But you can put if you go directly from the node.
Yep, if you can go directly from the node, you have 2 true drivers. You can have a 20-watt fixture on one side and a 10-watt fixture on the other side.
You just can't go over the wattage. That's 40 watts, right?
48.
48. Most of the lights only have one connector on the back, or you can daisy chain them from the light.
No, you can't daisy chain from the light. Only the A and B. So if you have a master slave A and B combination, you'll be able to bring in the PoE, and then you'll have an output so you can daisy chain only one after.
And on that option, you don't use the node, correct?
The node will be inside already, the fixture.
The light, okay.
Correct. So you'll be able to come in and you'll have a cable here. This will be covered. You'll have one output to the second light.
Okay.
Why are these 2 better than that one?
Good question.
On all of them?
Very good question. These stations, the wattage on every driver is specifically assigned to a specific wattage. Part of lab 2 is you actually have to change the wattage from one to another. And you'll be able to see when I drop the wattage out of driver 1 and I want, let's say 10 watt, you'll be able to see that the lights would actually match. If you put 20 watt on driver 1 since you're driving 2 lights and 10 watt on driver 2. Because
You do that on computer?
yes. So all the wattage gets done on the computer. All our lights will be sent out with 10 watt per driver. So all the lights would have 10 watt output for every driver. In the field, when you plug it in, it's going to look dimmer. The reason why we can't specify the wattage up front, because we don't know where these nodes are going to be put on in the field. We don't know where you're going to actually place them. You're going to have 3 lights, or you're going to have 2 lights. You're going to have 1 light. So we'll send them all with 10 watt output, and then in the field you could walk with a tablet or a computer and be able to actually alter the wattage appropriately depending on how many are connected. Now in this case, it doesn't matter in the field if you swap them. It doesn't matter if you have driver 1 or driver 2, because you'll be able to go in the laptop or computer and say, okay, I want driver 2 to have 20 watt and I want driver 1 to have 10 watt, as long as you know where you plugged it in. As far as the wall switch, pretty simple. You took the wire from there and straightforward. You can see that these now, they're connected into the same room, and part of the software is you actually have to spread them in different rooms. And you can see that any of your wall switches will be able to control all of those 4 lights. So if one person, here we go, Mike was first, shuts it off, you'll be able to shut 4 stations off. Later on, we're going to be able to split them into 4 different rooms, and you'll be able to do that. All the lights that go in the field, they'll be in the same group. So if you're connecting lights and you're connecting 100 rooms, and someone goes to the switch and press off, they might shut down the entire thing. After the commissioning, you have to tell those lights, go to this room, go to this room. After they're separated from their room, then they'll start behaving differently and only listen to the room that they're assigned to. All the stations have 7-button wall switch that will look slightly different in this material. This is a 4-button switch. On, off, up and down. You can turn the light on, turn it off, and turn it up and down. But there's also a 7-button scene. The scene controller allows you to control the scenes and change them depending on the configuration you want. You might want those 3 extra buttons to do 3 different things. You might want it to turn the light off when you're doing a video conferencing, or turn the light brighter when you're doing an audio conferencing, depending on the application. our scene control wall switch, you good. The off button says cancel, and the question is why? In order to get out of a scene when you're pressing it, you need to go out of that scene. Let's say, for example, I'm in a conference room and I press scene 1 and I'm doing something and the light is at whatever level and I want to go out of that mode. The cancel button would do that. So cancel is meant for scene controller to be out of a scene, and then you press it one more time and it's off. The 4 button does not have that. It has an icon and the icon shows the light off because there's no scenes involved. Right now we're going to connect driver 1. Driver 1 is the port on the top right going into the splitter, the input side of the splitter. Then we're going to take one other cable, come out of the splitter, and go into the back of the light. We're going to take the second cable, come out of the same splitter. It doesn't matter which port we connect it to. These 4 ports are exactly the same. We'll go to the second light. Lastly, we're going to take driver 2. We're going to connect to the last fixture. Then we will connect our control side into the back of the wall switch. We will press the up button to verify that all the connections are fine. Then cancel, we'll turn them all off. I'm going to go over a couple of questions. When we run the wires in the field and we ran it from here to the ceiling, there's a requirement of the amount of service loop that the contractor has to leave in the ceiling. And I think today we wanted 36 inches. We might go a little bit more than that. So think about it this way. Someone has ran the cable and left, and now I have to put these hi-hats in the ceiling. And if that cable is short an inch, we're going to have a problem. Because I can't move the ceiling up. I can't extend the RJ45. So it's best to leave some more. Go ahead.
You guys still sending the pre-cut cables and pre...
No.
Now, so you're running the cables from the box and do our own termination, right?
Right.
You want?
Correct?
Yeah.
Because the first time I was here, you guys were gonna send the pre-cut cables with
Yeah,
the
that was a while ago.
measurements.
New plans.
So we using cable from the box, correct?
Yep.
Okay, that's fine.
I'm not sure. Sorry. If you are doing that, so there's two steps to it. Now you're running the cable across, you're cutting it, terminating, or patching. What does that mean? What does termination mean? What does patching mean? There's 2 sides to an RJ45.
Sorry.
I wasn't going to answer. It's okay. There's 2 sides to an RJ45. This side that's patched, and there's a termination. Termination means that it goes to a back of a patch panel. What is a patch panel? Some people might ask. The patch panel is where this end become a female, and now I have a small cable where, think about it this way, if I had one of this, I'm going to have to bring 23 or 24 cables, look like this, to go here, from somewhere in the field. It's going to look like a big bundle coming down into a small switch. It's going to look like a mess. They invented a patch panel. You bring all this stuff in the back, and you'll see that there's wires going to the back, and with a small yellow patch cord, you'll be able to put and connect and troubleshoot. Take it out, put it back on.
Just punch them in the back.
Exactly. Punch it in the back. How do I verify that it's truly punched? Anybody? How do I make sure that I made a connection? Some of us might get tired, middle of the day, 12 o'clock, I've been punching all day and I missed that eighth pair. There's 8 of these. So every wire would have to punch 8 times. And we're talking about a punch, that means you have to physically do some manual labor into the back of the patch panel. How do I verify all of these wires are okay? Yes, so you use a tester. And that's mandatory. We need a fluke report that tells us that this is actually tested. Part of the problem is just like an electrical wire. If you run it and you forget to put a wire nuts, but usually you don't twist the cable, you leave them next to each other, vibration and all that, the next wire will drip or fall out.
So in case of Plymouth Village, for example, the 9th is going to be the first one we're going to do. You guys need all cables certificated?
Absolutely.
It's part of the pull schedule. There's a line that says certified, and then you just have to say certified. I take your word that you did it on the field.
You guys want the reports from the unit, because we have both tested. We have already tested out, prints out a report.
Yes, the one that prints out the report, and then that's a document that proves that you checked it. When you check it, you only do it a check mark, but in the field, down the road, day 2, day 3, a month later, someone complains about that fixture because it's not getting the right power, or it's not communicating properly. It takes time through a couple of iterations. Then we were going to say, okay, did you actually fluke that? And the report will say, okay, that cable is actually certified. It just eliminates that portion of, we don't have to blame it on the cable. So this is what a switch would look like, or there's an 8-port model. The 8-port would have 8-port of it, and then there's an uplink. What is an uplink? Why do we need an uplink? So we talked about, I'm connecting one wire, and I'm going to a couple of lights, or maybe to a fixture. But now I'm throwing another term, uplink. What does that mean?
To send data to the next source.
Yes, to send data to the next port. Excellent. So how does the network connect in? And this is important for the people that actually spec the project and the people that install the project. When you're speccing it, you don't, okay, I understand that I need one port for a bunch of lights. 1, 2, 3, 8. I also need a port where I can take this information and take it to the next switch, the next switch. Think of it this way. This is a network. Everything is connected together. Physically, you have to connect everything together somehow. If I have in Pier Village, you have 8 ports. 8-port switches. And there's a wire that goes from every 8 port and daisy chain into the next one. So the information from every port, from every switch, carries along all the way to the inspeXtor. There's only one inspeXtor per network, but these switches, these PoE switches, has to be connected to each other. Understood?
So in Pier Village, is there going to be one inspector or 3 inspectors for the 3 buildings?
So
Every network would have one inspector, so three inspectors.
inspector? Is it another Cisco switch?
The inspector is the software. All the GUI, the controls.
It all goes to an inspector. Is it connected to something?
Yes, so the inspector is something that looks like this. It's a black server that gets installed. And then from there, you connect to the Cisco switch. But there's another problem. I have 10 switches, and I only have one inspector. And I'm saying I got to connect all these to one inspector. How does that even work, physically?
you jump from switch to switch.
Let's say I did that. I came and I have now 10 cables. I have 10 switches. That means I have 10 actual cables. Where do I put them? How do I take these 10 and make them go into one inspector? I need a core switch. Another major important item that sometimes gets missed in the project. Either you don't spec it, or we don't actually put the cables into the core switch. After we take all these wires that came out of the switch, I need one aggregator switch, or a core switch, or a link switch, whatever you want to call that, where I take all these cables and put them in there, and then from there, only one cable goes to the inspector. The inspector only has one cable. But something got to take all this, put it together, and then you make the last connection. Usually the core switch is next to an inspector, and it's usually in the MDF. Yes, so the signal will split out of the core switch, goes to every switch downstream. So far, so good? We talked about that. Do I need to run this back to the wall switch back all the way to here? No. You run all the way into the fixture and you're good to go. Can I connect a downlight from this cable? I come out of a PoE switch and I go to the downlight. Would it light? Anybody? No. It won't light. There's no technology inside that light, so it's not going to light.
Only the one with the node.
Integrated, that's the pendant, that's this fixture right here, that's hanging, that fixture, you'll see that the cable went right through to the fixture. But a small one like this, you can't take it directly from your power or your switch going directly to it, because there's nothing in it. We have to go through some sort of technology.
Yeah, it receives the power, but doesn't receive the signal. So
Exactly. It would receive the power, but not the signal. It won't even negotiate. You can take it directly to the node only if there's one of them. But if there's two, you might run into a scenario where you have a corridor or a conference room where you have two doors, and you want two wall switches to go to one node. You can do that. Just add one of these to it, and then you'll run the first one into here. You run the second one into here, and you come to the
Okay, but the switch has always to be landed on the control side. on the top.
Absolutely.
Okay.
That's true. For the installers, yes. You can't take the wall switch cable and put it into the driver's side. It will not work. And sometimes it will burn it. Can you connect more than one? Yes. This device, the splitter, I should get one up here. The splitter does not differentiate whether it's power or peripheral. So you can just take any of them from the shelf or from the box and put it in. What's important is recognizing which node I actually put in there. And we'll go through how you actually find out which node you actually put in the ceiling. Connection-wise, you'll see the splitter goes into the T for whoever's going to install it. You can see that it clips onto the T, so it stays that way. And in the ceiling, you can visibly see it.
Oh, that's cool.
Yeah, but only a sheetrock ceiling, you just land it on a sheetrock. Oh, you want
Put it on a sheetrock. How are we installing it today?
How are we installing it?
If there's a drop ceiling,
There's no drop ceiling.
If there's
it's
no
a
drop
hard ceiling.
Oh.
Okay, and that light, you definitely cannot put the drill through that light to secure the splitter or the node to the whatever is above the ceiling,
Yeah.
of the sheetrock. So you just bring the cable, do the terminations, plug it in. Before you put the light, you just land those devices on the ceiling. Then you put the light.
That's correct.
Okay.
Yes.
Just in case the client doesn't want to use access panels. Correct.
Correct. But then that gives us another. Remember the columns that we had? We're looking at your light.
I don't want you to lean.
Your light's
Pour
going to
coffee
act
on it.
as the access panel.
Exactly.
So we need to know, like, if we're running multiple downlights, we need to know out of that
Which-
run
which
which
one
one are the node or driver and splitters close to, so that we can access it.
Okay.
All right.
Another one is what's the limitation from the splitter to the light? 25 feet cable. So you got to strategically put that splitter somewhere in the middle where you have PoE coming into the node, and then you have 25 feet this way, and maybe you put it in the middle and you go spread out to the left and to the right.
I think specifically in this, we're in Pure Village. We're running in the corridor, your lighting downlights, and out of a group of 10, I'm sorry, it's out of a group of seven lights, 4 of them are going to be regular lights. 3 of them are going to be EM. And so you have to put your node, run your power to your node, and then run that power to a battery. So that's an extra step. And then you run the power out of that battery to a splitter. And that splitter is going to go to 1, 2, 3 lights.
Okay, so the battery doesn't come with the light. The battery
In
is apart
this-
from the light.
In this case, because we're running multiple lights off of one battery, the battery is external. In other cases, like if we have a strip light, the battery will be
On the light.
internal, an integral battery. Go ahead.
I'm sorry. How big is the battery? It's like
I'm
a.
gonna send somebody down, and then I'll get you the
Yeah.
product, and then you'll be able to
You'll
get
see
it.
it.
That.
It's about this big. You'll see that flash.
Okay, because that comes again the question where to locate the battery. Above the
It's just sit
ceiling.
on the sheetrock as well.
It's gonna
Yep.
sit on the sheetrock as well.
Yep.
Okay.
Yeah,
It's-
these things don't give off heat.
Yeah, sorry. It's as small as the node, and you'll be able to see it. I'll get someone to get it. It's gonna have 3 outputs, or 3 RJ45s. One is in from the driver, so you'll come out of the driver, you'll go into an out in it, and an output back to the splitter. So it's like a pass-through.
And do you have any distance wise from the battery to the light?
Less than 10 feet,
Less than 20 feet again?
less than 25 feet.
Okay. So basically, if you have a emergency light, for example, one in the middle, one in each end, you have to put the node and the battery on the middle and.
Yes. What basically has to happen is you have your node, you bring the power in, then you'll come out, you go immediately to a battery. I would just put it like a 6-inch to the battery and then come out of the battery, and now I still have my 25 feet. And the output is what powers only the battery, and that's what has to be labeled. The 3 lights on the battery. And it's the same for, I guess, the pull schedule. Whoever is running the wires on the pull schedule have to understand that there's a limitation only to 8 watt that gets delivered from that battery for 90 minutes. So you got to be careful how you actually distribute lighting when you only have 8 watt of battery left.
And understand that the battery is designed to run the fixture at a lower output because it's egress lighting. So you're running like 2.5 watts as so it's 8 divided by 3 because we're going to 3 lights. So, and that's how you'll get your 90 minutes. If we put it on a different type of fixture, it's interval, it's still going to deliver 8 watts, but that would be to just one fixture. So that the egress rules are still adhered to. You're providing that light level in the corridor, but it's at a reduced amount than the normal,
Because you're splitting between
because you're
two
splitting.
lights.